Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 11, using half-angle identities, Part 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we derived the half-angle identities. You see all 5 of them here. One for cosine of x over 2, one for sine of x over 2, and 3 for tangent of x over 2. Any identity that involves a plus minus, the sign, SIGN, is selected based on the trig function and the quadrant of x over 2. In this video, we use half-angle identities to evaluate trig functions, so let's get right to it. For example, find the exact value of cosine of 15 degrees. Now, some of you might be thinking we can do this using a cosine difference formula, since 15 is equal to 45 minus 30, and we know everything about those two angles, but we can also use a half angle formula since 15 is half of 30. So we view 15 as half of 30, as I just mentioned. Cosine of 15 degrees equals cosine of 30 degrees over 2. Now let's apply the cosine half angle identity to 30 degrees over 2. So basically we're pretending in this first identity that x is 30. So cosine of 15 degrees is the square root of 1 plus cosine of 30 degrees over 2. Of course, we know the cosine of 30 degrees, or we can calculate it. It's the square root of 3 over 2. And now we're just on a mission to clean up this answer. First off, we have fractions inside of fractions. We can always clear that out by multiplying both sides of the big fraction by the denominator of the little fraction. So let's multiply both sides of this by 2. And when we do that, the 2 on the bottom will multiply to give 4, and the 2 on the top will distribute, turning the 1 into a 2, and canceling the denominator, giving us the square root of 2 plus the square root of 3 over 4, all of it in the square root. Now, speaking of square roots, I know the square root of 4. So we could split this square root of a fraction into a fraction of square roots by putting the square root on both sides, and the square root of the denominator would become just 2. Square root of 4 is 2. The top, however, what are you going to do with that? There's actually something you can do, but for now, that's a perfectly acceptable answer. Cosine of 15 degrees equals the square root of 2 plus the square root of 3, all over 2. Now, it is worth mentioning, as I already did, that if we used a cosine difference identity, we'd get cosine of 45 degrees minus 30 degrees equals cosine of 45 degrees times cosine of 30 degrees plus sine of 45 degrees, sine of 30 degrees. And if we substitute all the values and clean it up, we get the square root of 6 plus the square root of 2, all over 2. Clearly a different looking answer than this one. So I challenge you to show that these two rational expressions involving square roots are equal. Show it algebraically, meaning can you transform one into the other? If you put them in a calculator, they'll give you the same decimal. That's not a proof. That's evidence. Let's try one more. Find the exact value of 22.5 degrees using, and I'm telling you specifically which one to use, tangent of x over 2 equals sine of x over 1 plus cosine of x. Now, it's worth mentioning that we have 3 choices for tangent. I can go back real quick and show you what they were. These 3 on the bottom down here. But there's a reason why I want to use this one, because I want to show you a move that may or may not be in your skill set. All right, so we need to view 22.5 degrees as half of an angle. That's half of 45 degrees. So using this half angle formula, tangent of 22.5 degrees is sine of 45 degrees over 1 plus cosine of 45 degrees. Of course, we know both of those. Both of those are square root of 2 over 2. And we have little fractions inside of big fractions, so we'll resort to multiplying both sides of the big fraction by the common denominator of the little fractions, which is 2. So times 2 on both sides. We'll cancel the 2 here. Now, I don't know why I don't have the steps showing the times 2, but we should be savvy enough that we can see it, and if not, then I'll just illustrate it real quick. Multiply both sides of this by 2, which will cancel the 2 down here, and on the other half it'll distribute. It'll cancel the 2 in the denominator, but it'll also turn the 1 into a 2. So we get square root of 2 over 2 plus square root of 2, just like that. Now, this is a denominator with an irrational number, and there is a way to rationalize it. We use conjugates. To rationalize the denominator, We do it by multiplying both sides by the conjugate of the denominator. So we're going to multiply both sides by 2 minus the square root of 2, which will invoke the distributive property on top and a difference of squares on the bottom. We'll get 2 squared minus the square root of 2 squared on the bottom. Well, 2 squared is 4, and the square root of 2 squared is 2, so the bottom just becomes 4 minus 2, better known as 2. And of course, the 2 on the top, the square root of 2 gets distributed on the top. Well, now this fraction will reduce because everything is a multiple of 2. Reduce everything by 2, then this, there it is. This becomes 1, this becomes 1, and this becomes 1, but over 1 doesn't matter, so we just get square root of 2 minus 1. Now you try. Pause the video and try the following. Use a half-angle identity to evaluate cosine of 165 degrees. Pause the video, give it a try. All right, here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1. If we're going to use a half-angle identity, we need to identify that or note or calculate that 165 degrees is half of 330 degrees. So cosine of 165 degrees equals negative square root of 1 plus cosine 330 degrees over 2. And the negative was chosen because in cosine in quadrant 2, where 165 degrees is negative. And then we end up getting an expression that we clean up similar to before.